This is problem number 8 on the sample test problems for test number 3. A bracket is subjected to the 3 forces shown in the diagram below. Resolve each of the 3 forces into components. Note that nothing is to scale. Okay, we'll start with the top force. The top force is pulling up this way, up and to the right. The angle that I'm interested in is the sum, 50 degrees. Remember, we're still doing our standard position for angles from the positive x-axis and then going counterclockwise, so that's 50 degrees. And the pull, the magnitude of this thing is 2.4. So we're going to use one of our familiar looking formulas. We know that the x is the r times the cosine of theta, and the y is the r times sine of theta, where r is just the magnitude of the force. So in this case, r is 2.4. Cosine of the total angle is 50 degrees. And then down here, it's 2.4 sine of 50 degrees. And then we'll go ahead and type those into the calculator to get our estimates. Okay, so we go 2.4 cosine of 50 degrees. If you hit sine, cosine, or tangent, make sure you think about the mode. We need to be in degree mode for this problem. So 2.4 cosine 50. And I know that I'm going to use that number later, so I'm going to go ahead and store that as A. So I hit the green number and then the A, or the green button and then the A. And then 2.4 sine of 50. And that's about 1.83, and then we're going to store that as B, alpha B. Okay, so we've got our two numbers, 1.54, 1.84. Okay, that's the top force. We'll go ahead and do the next force. The next force is just the angle 20, and I can't really see what's happening there. Is that a 1.85? Okay, so we'll just do this one now, just a 20-degree angle and a 1.85. Same idea. So we're going to do 1.85 times the cosine of 20. 1.85 times the sine of 20. So we'll type these ones in. 1.85 cosine of 20. And then we'll store that one as C. And then we'll do the same thing down here, 1.85 sine of 20. And we'll go ahead and store that one as D, alpha D. Okay, so our two numbers here, 1.74 and 0.63. And then the last one, this is force going down here. So it's a 1.4 is the magnitude of the force. The angle is 35. However, this is below, and in terms of our standard position angles, the theta that we see here is actually negative 35 degrees. It's okay to not really recognize that. I mean, it's kind of nice to let the sine and cosine take care of everything. But if you don't see that, at the very least, you should see that we're still pulling to the right as we go this way. So it should be a positive x pull. But this is pulling down in some sense. So the pull down, the y value, should be a negative number, even if you don't catch it right there with the negative angle. So let's try this one here, x and y. R is now, does that say 1.4? 1.4 cosine of negative 35 degrees. And 1.4 sine of negative 35. 1.4 cosine negative 35. What's that one? I'll store that as alpha E. Oops, store as alpha E. And then finally 1.4 sine of negative 35. This is the one that's supposed to be a negative because we are pulling in the downward direction in terms of the vertical. And so we get that negative number, and then we're going to store that as F. Okay, so we've got 1.15 and negative 0.80. And then part B says find the resultant, the sum of the three forces. So what we'd like to do is add up, What we'd like to do is add up the x's and separately add up the y's. So this is going to be the resultant x's and y's. So we're adding the x's, 1.54 plus 1.74 plus 1.15, and then adding the y's, 1.84, 0.63, and then minus a 0.80, or a plus negative 0.80. But I don't want to type all those things in again. We did all that work so that we wouldn't have to. So all I want to do here is do alpha A plus alpha C plus alpha E. Those every other ones were the x's, and then the y's were the B and the D and the F. So we get 4.43 and 1.67. And then finally, the direction and the magnitude of the resultant. In part C, to find the magnitude, we use our familiar formula. R is equal to the square root of x squared plus y squared, using the x and the y that we just found. So let's use that on the calculator. Probably should have stored these numbers. So let's store the second one right here. E, F, G, H. Let's go H with that one. And then I'll do second enter a couple of times and get this one. That's not what I wanted. I want that one, and we'll go ahead and store that one as E, F, G. Store that as G. Okay, so the numbers that we have here are in order x and y become g and h. So what I'm really interested in doing is doing the g squared plus the h squared, and then the square root of that. Alpha g squared plus square root of alpha h squared. So I think too many square roots. So I think everything there is okay. So we go alpha h squared. And that should be the value of r, 4.73. And then finally, we need the value of the angle. So we use the other familiar formula for us. That the theta is the inverse tan of the y over the x. And we'll just type that straight into the calculator. Second tan of the y over the x. So that was the h over the g. Yes. Alpha h divided by alpha g. And it's about 20.64 degrees. So that last part means that these three forces that are pulling in three different directions with three different magnitudes are really the same as a single force pulling with a magnitude of 4.73 kilonewtons at an angle of about 20 degrees.